Okay, so welcome to today's lesson. Um, for those who are joining for the first time, this is Tutor Poul Solutions from IQ Academy, and we started our classes yesterday with math. We were looking at set theory. So today we are doing chemistry, okay, and we are doing this topic which is units and measurements. Okay, so this topic units and measurement will also be taught in physics. Okay, so we will be introducing it today. I'll also be introducing it in physics. Okay, so it's the same things, units and measurements. Okay, so what differs is just about the dimensional analysis. Okay, so when we come to chemistry, when we say dimensional analysis, we'll just be referring to a method that we use to convert units, okay, from one form of the units to the other. Okay, that's what dimension analysis would be meaning in chemistry. And then when you go to physics, okay, and then you hear the word of dimension analysis, it will mean something different, okay, where you are checking the correctness of a given formula. Okay, so our objectives in this lesson are: one, to define a measurement, okay, and then we are going to look at the fundamental SI units. So we have 7 of them, okay, and then we are also going to learn about the metric system. Okay, so this is just simply a system based on the multiples and submultiples of 10. Okay, and then once we are done learning the metric system, we are going to look at how we can convert units, okay, using this metric system here. Okay, so we are going to solve uh, example questions on the unit conversions. Okay, so this is our roadmap for today's lesson. Okay, so let's define what a measurement is. So anyone who can help us, what do you think a measurement is? Anyone? What is a measurement? No, we've heard of this word before. So what is a measurement? Okay, what is a measurement? Okay, so let me define it. So here I have the definition of what a measurement is. Okay, so a measurement is simply a quantitative observation consisting of a number and a unit. Okay, so very important. So for something to be called a measurement, okay, then it has to have one, a number and a unit. So for example, if I write 10 kg, this 10 kg here is a measurement. Why? Because it has a unit and a number there. Okay, so this kg is a unit, then that 10 is a number. So let me write 20 kilometers. Okay, even this one here is a measurement because it has the number and a unit there. Okay, but in the case where I just write 20, okay, so this 20 here won't be a measurement. Okay, because why? It doesn't have any units attached to it, so it can't be a measurement. Okay, so a measurement, always you have to remember that it has two parts, okay, the number and the unit. Okay, so both parts must be present for it to be called a what? A measurement, or for the measurement to be meaningful. Okay, you have to have a number and then a unit what? Attached. Okay, so we have 7 very important units, and we call them as the fundamental units or the SI units. Okay, so from these units, they're just 7. Okay, from these units, they're just 7. We can come up with any units that you can think of in this world. Okay, so those units like the newtons, the joules, the watts, the pascals, okay, all these units here will be coming from what? These 7 fundamental SI units. Okay, so once you know these units, then you can come up with any other units that you want. Okay, so let's look at those units here. So you can see here there's a table that I've put for you guys. Okay, so these are the 7 fundamental units. So we have the quantity here, okay, the name of the quantity, the symbol that is used for that quantity, okay, and then we have the name of the unit in which that quantity is measured, and then the symbol of that unit. Okay, so the first one is time. Okay, so time is one of the what? SI units. Okay, so its representation, we say it's a small letter t, then we mean that we are referring to what? To time. And then we know that the SI units for time are just what? Seconds. Okay, but we also know that this time can also be measured in hours. Okay, it can be measured in minutes, it can be measured in days, in years, okay, just like that. But the SI units for time, always know that it's what? The second. Okay, so the second is the SI unit for time. And then we can also talk about the length. Okay, so the length, what is used to represent the length? Okay, so we have quite a number of representation for the length. You can use L, you can mean length. Okay, you can use X, it will still mean length. Okay, it can be R. Okay, sometimes when you're talking about the equations of motion in physics, we're going to use S, okay, as the representation of this length. Okay, so this length is measured in meters. So meters are the SI units for what? For length. Okay, and we know we also have other units for length. We have kilometers, okay, centimeters, just like that. All right, and then we can talk about the mass now. Okay, so the mass, its symbol is M, and then the SI unit, okay, is just the what? The kilogram. And then for the current, okay, the symbol is I, okay, capital letter I or small letter I, and then the units that they use are the amperes, and the symbol for the ampere is just a capital letter A. Okay, and then we have thermodynamic temperature. Okay, so thermodynamic temperature is represented by capital letter T, and its units are kelvins. Okay, so most students get it wrong. They think the base unit for temperature is the degrees Celsius. No. Okay, so the base units for temperature are kelvins. So later on you are going to learn how to convert these kelvins to degrees Celsius, from the degrees Celsius to kelvins. Okay, and then now we have the amount of substance, okay, as the base quantity. So this amount of substance is represented by a small letter n. Someone has their mic and mute. Please mute yourself. Someone has a question? You are saying? I didn't get you.
I was asking, so when can we use degrees Celsius?
Oh, it's just it depends on the question that you are asked. Okay, but here I'm just explaining the base units. Okay, so the base units for temperature are kelvins, but you can represent temperature in either the degrees Celsius or the kelvins. Okay, so it doesn't matter when and when can you not use them. Okay, it just depends with the scenario or the question. So if they give you a question, they will make sure that they they tell you the units to use. Okay, either it's the degrees Celsius or the kelvins. Right, and then I was explaining about the amount of substance. So this amount of substance will be the center of whatever you're going to do in your chemistry course. Okay, why? Because this amount of substance is measured in moles. So whatever you're going to do in chemistry, okay, it will just be based on moles, 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 moles. Find the moles. Okay, whatever you are finding, okay, it will be mostly based on the what? The moles. Right, and then we have another one here, which is the third one. Okay, so the third one is called luminous intensity. So you don't usually learn anything about this, okay, unless for those who are doing who are majoring in physics and they are learning about light and the stuff. Okay, those are the guys that do luminous intensity. So it's important to know that it's measured in candela, and the symbol for candela just what? CD there. Okay, so these are the base units that we have. Okay, these are the base units that we have. And then when representing these measurements that we define, that they need to have a number and a unit. Okay, when writing them out, when defining them, okay, it's not always convenient to use only these units that we can see here, the SI units. Okay, so we might change. For example, from the meter, I might change to centimeter. Okay, from the kilogram, I might change to gram, I might change to gigagram, okay, to picogram, just like that. Okay, so what gives us the power now to change to all those other units that I'm mentioning here? Okay, what gives us that power is what we call as the metric system. Okay, so now we are going to talk about this metric system. So what is the metric system? Okay, so this is just a scientific system of measurements that is based on 10 and multiples and sub-multiples of what? 10. So this metric system is just simply a table that has one prefixes, okay, and then the values of that of those prefixes. Okay, so depending on the prefix that you are using in a certain measurement, okay, you'll be able to tell its value when you change it to the base unit. Okay, so let me show you the metric system here. So this is the metric system, the one that you can see on my screen. Okay, so the metric system is based on 10 and multiples and sub multiples of 10. So when we come here where it's written magnitude, okay, you've seen this column here. Okay, you can see we have 10 to the power something, 10 to the power something. Okay, so if the power is a positive power, then we say that that is a multiple of what? 10. Okay, so you can write multiple there. That's a multiple of 10. And then here down I can see I have -1, -2. I have negative powers. So if you have negative powers, we call that as sub multiples of what? 10. Okay, so these values here, all of them that you are seeing, they have a name attached to them, and that name that is attached to them is what we're calling as a prefix. Okay, so for example, if I say tera, okay, if I say terameters, then I just mean 10 to the power 12 meters. Okay, maybe let me say something that is common to you guys. So let me say kilograms. So I'm here where the kilo is. When I say kilograms, okay, or when I say 1 kilogram, it means I just mean 10 to the power 3 kilo, 10 to the power 3 uh, kilograms, like that. Okay, so these here are prefixes and they have their own numbers that are attached to them. So you have to know what each of these prefixes here, okay, what each of these mean here. You have to know them. Okay, so you have to know that when they say tera, okay, they just mean 10 to the power what. Okay, when they say kilo, they just mean 10 to the power 3. Okay, when they say centi, those centimeters that you are used to saying, okay, when they say centimeters, okay, that word there in the centimeters, the centi represents what? 10 to the power -2. Okay, so this is a table that you must know for you to convert these units that we are going to be converting easily. Okay, so what happens now when you are converting units is that you are going to get your base units and put it in this row here where I'm drawing this red line. Okay, so you've seen this row here where I'm drawing a red line here. Okay, it doesn't have any prefix here, there's just unit here. So you are going to put your base unit here. Okay, you're going to put your base unit, and then that base unit you can either change it to the multiples of 10, okay, or you can change it to the what? To the sub multiples of 10. Okay, so you're going to put your base unit here. So for example, if I put let me say I put 1 gram. Okay, so this 1 gram here, I can change it to the multiples of this gram. Okay, so the multiples of this gram can be decagram. Okay, I can convert that 1 gram to decagram. I can convert hectogram to the grams. I can convert kilograms to the grams, or I can convert the grams to the kilograms. Okay, so even here it's the same. So let's say maybe here I have meters. Okay, so if I have meters there, okay, if I have meters there, I can convert these meters to any of the sub multiples of 10 here. Okay, so I can convert these meters to decimeters, centimeters, millimeters, micrometers, nanometers, pico meters like that. Okay, so it's very important for you to master this metric system that you are seeing here. So when you just hear centi, okay, you know centi is associated to 10 to the power minus um, minus 2. Okay, when you hear pico, just know that it's 10 to the power minus what? 12. So you must be able to make those comprehensions as you go on in this course and you're told to change these units. Okay, so we are going to do a number of questions on this very concept, okay, just to see if we understand uh, whatever I've explained here. Okay, and then afterwards I'll give you an assignment to do, okay, based on this same conversion of units here. Okay, so when you go to the next step here, now we can solve some example questions where we are converting units. Okay, so I must mention that we have about 3 ways of converting units from one form to the other. Okay, so the first one is called the direct. Yes.
I haven't understood on the metric system. Can you please repeat?
Okay. All right. So the metric system, I was saying, it's simply a tool, okay, that has multiples and submultiples of 10, I mean. Okay, so this metric system here, it has one, I said it has prefixes, okay, and then those prefixes, okay, have, of course, they have symbols, and then they have magnitudes there. So depending on the prefix that you are dealing with, okay, depending on the prefix that you are dealing with, it's going to have a specific value. Okay, so I'm sure most of you are on Facebook, right? So on Facebook, on that like button, you sometimes you see they write like 1M like that. Okay, so this 1M, what does it mean? It means that that post has gained 1 million likes. Okay, 1 million likes. So this M here from that Facebook post or from your TikTok. I know most of you guys love TikTok, okay? When you see 1M on that TikTok video, that M there is a prefix. That means what? Mega. And it has a value that is attached to it, okay? So the value that is attached to that M is simply 10 to the power 6. And 10 to the power 6 is the same as 1 million, okay? So there are a lot of prefixes, as you can see here, and each of them have a different value. So when you are converting now, okay, when you are converting your base units to these multiples and submultiples of 10, okay, you're just going to be using the values of these prefixes to convert. So maybe let's do an example and then you understand better. Okay, let's do an example. So I was saying when you are converting now, we have 3 methods. We have the direct method, the one that we'll use today, okay, where we're just using the metric system, and then we have dimensional analysis. Okay, we have dimensional analysis, and then the third one we have the one where we use conversion factors. Okay, so what is a conversion factor? Those things that you are doing in grade 12. Okay, maybe we say 1 kilometer is equals to how many meters? Okay, we are saying 1000 meters. Okay, so this is a conversion factor. So we can convert units using the direct, dimensional, or using what? Conversion factor. So you see here, this 1 kilometer simply means 1000 meters. So what has changed? It's just that we have replaced this kilo here with its value. So when you go to the metric table here, you know that we see that a kilo there is just 10 to the power 3. So what is 10 to the power 3? Is 10 multiplied by 10 multiplied by 10. So 10 multiplied by 10 multiplied by 10 is going to give you what? 1000. So this is the same method that we are going to be using under what? Direct conversions there. We are going to be converting from a certain given unit to a smaller unit. Okay, so now let's do some examples for more comprehension and understanding of this concept. Okay, so we are converting these units using the direct substitution. Okay, and then later on in other lessons we are going to use the dimensional analysis and the conversion by what? Factors. Okay, so the first example I'll give is convert Okay, let's convert 3 kgs to grams. Okay, so how can we convert that 3 kg to grams? Okay, so the conversion is very easy when we are using the metric system. So this is what we are going to do. Okay, this is what we are going to do. I'm going to write 3, okay, k, and then g. Okay, so for me to convert this 3 kg to grams, okay, I just have to replace this k. Okay, this k here, I just have to replace it with the value from the metric system there. Okay, so what is the value of k from this metric table here? We see that the value of k, which is the same as kilo, is just 10 to the power 3. Okay, so meaning converting this 3 kg to grams, I'll just write 3 multiplied by, and then where there's k here, I'm going to put the value from the metric table. So the value from the metric table will be 10 to the power 3 and then grams. Okay, and then from this now you can just use your calculator. Okay, so 3 multiplied by 10 to the power 3, what is it going to give you? Okay, someone has a question? Vincent, you have a question? Yes.
When we use this method, would we lose marks during the exam?
No, you won't lose marks. It's one of the methods for converting, so you won't lose any marks. Yes. Okay, so we are going to replace this k here with its value from the metric table, which is 10 to the power what? 3. And then we know that 10 to the power 3 is just a 1000 like that. Okay, so it will be 3 multiplied by this 1000, it will give you 3000 grams. Okay, so 3 kg is the same as what? 3000 grams. Okay, so we have used the direct conversion there. So any questions there before we do another example? Okay, no question. Let me write up another example here. Okay, okay, so I want us to take it step by step. So today we are just going to focus on converting using the metric system. Okay, so another example would be let's say 9 centimeters. Okay, let's convert this to meters. Okay, so what do you think we should do in order to convert this to meters? Okay, it's very easy. We are just going to write 9 cm. Okay, and then let us replace the value of this cent there with its value from the metric table. So its value from the metric table will just be what? 10 to the power minus 2. So this will be 10 to the power minus 2. So this value here is 10 to the power minus 2. That's where we can see the c here. Okay, so we're going to write this is the same as 9, okay, multiplied by, where the c there we put the value of the centi from the metric table, which is just 10 to the power minus what? 2. And then we write meters. Okay, so punch this value on your calculator and then we see the value that you're going to get. Okay, so what value are you going to get if you punch this on your calculator? My calculator is showing me 0.09 meters. Okay, so we've moved from centimeters to meters using a direct what? Substitution of the value of this centi here. All right, so let's do another example. Okay, so this one, let's make it to be about volume. Okay, let's make it to be about volume. So for example, let us convert 4 microliters to what? To liters. So from this conversion here, okay, what are we going to do? We're just going to substitute this here with its value from the metric table. So I'm going to write 4 multiplied by, what's the value of the micro from the metric table? Okay, so when I look at the metric table there, the value of that micro will just be what? 10 to the power minus 6. So I'm going to write 10 to the power minus 6 here and then multiplied by the liter is still there like that. So this is going to be equals to, we just multiply now. This 4 multiplied by 10 to the power minus 6 on your calculator. Okay, what are you going to get? Okay, so you're going to get a very big decimal number. Okay, so this one is best to just leave it in scientific notation. So we're just going to say this is the same as 4 multiplied by 6, 4 multiplied by 10 to the power minus 6 liters, like that. Okay, so I think you get the idea now of what we are doing, right? Okay, so let us solve another question now, which is a bit different, and it involves two conversions. Okay,
I have a question, sir.
okay, what's your question?
When we after converting,
Mm-hmm.
if you want to prove,
If you want,
can you prove?
if you want to do what?
If you want to prove that, if you want to prove after finding the answer,
You want to prove what?
like for example, the first example, okay, example for 9 centimeters you gave us.
Mm-hmm.
After finding the answer, like you want to prove, can you, will it take you back to the question?
Yes, it will take you back to the same unit. Okay, so now when you are proving from a multiple, or I mean when you are coming from a multiple or a sub-multiple to the SI unit, okay, so there you have to use a conversion factor. Okay, so when you use that conversion factor, it will take you right back to where you came from.
Right.
Yes, okay, but today I don't want to do any questions on conversion factors. Okay, so where was I now? Okay, I was supposed to give another example. So let's say, for example, we have this question here. They're saying convert 5, let's say 5 kilometers. Okay, convert these 5 kilometers to meters. Okay, so what are we going to do here? We are going to do the same thing that we did. Okay, so we are just going to replace this guy here, the kilo, with its value. So it will be 5 multiplied by, okay, 5 multiplied by, and then here we are going to look for the kilo, which is 10 to the power 3. So 10 to the power 3, and then we have the meters there. So we multiply that, you're going to have 5,000, like that, and then these will be meters, like that. Okay, so any questions on using the direct method to convert these units? Any questions? Yes, you can ask, Vincent.
I wanted to I think there are bigger, mega, kilo, and so on. These are prefixes of SI units, right?
I can't get you. What are you saying?
Uh, I'm saying that uh, tera, giga, mega, kilo, hecta.
I think your network is bad. I can't get you. Anyone who can get what he's saying.
Prefixes of SI units.
Okay, you're asking that these prefixes here that we have are prefixes for SI units. Is that your question? Anyone who can get the question that he's trying to ask. I can't get him, like he's breaking.
We can't get him.
Okay, you can't get him as well, right?
Yes. He said yes, that was his question.
Okay, so okay. So we are saying he's asking that if these prefixes here are for SI units, okay? So these prefixes here can be used anywhere, okay, can be used anywhere. So even those other units that you get when you combine the SI units. So I gave an example of a liter here, okay. So this liter here is not an SI unit, but we still use the prefixes, okay. So you can apply them to the fundamental SI units, and then you can also apply them to what we call as the derived units. derived units. So the meaning won't change. So for example, if you have maybe you are finding power, okay, and we know that power will be given in watts. We know that power is measured in watts, right? Okay, power is measured in watts. So you can still use this matrix table to describe the magnitude of this power. So let's say I have 10 um, 10 kilowatts. Okay, so let's say I have 10 kilowatt. It will still mean the same. This kilo here, okay, from the matrix table, we just know that it's 10 to the power 3 there. So this will be the same as 10 multiplied by 10 to the power 3 and then watts. Okay, so the matrix system still applies to any other units. Okay, not only the fundamental um, base units. Okay, so that's how we do the direct conversions. Okay, and then next time when we meet, I'll introduce you guys to conversion factors and what we call as the dimension analysis. Okay, someone has a question, you can ask, sir.
My question is continued. Since I'm getting the continued in the chat,
Okay, what's your question?
my question is if those are prefixes, then what is the extra unit for mass? Since kilo is the prefix.
Come again.
My question is if
uh,
those were prefixes, then what is the SI unit of mass if kilo in the kilogram is a prefix?
okay, so for mass, okay, let me go back to the table. I think for mass, I don't know why they put a prefix there as the SI units, but that was the agreement of the scientists who are coming up with these things. So you can see here when we go for when we go on mass there, okay, and when we check the SI unit, okay, when you check the SI unit for mass, they're saying it's a kilogram, okay, but this kilogram here is it's a multiple, okay, of a gram, okay. So on the mass here, it's just based on the agreement of the scientists who are coming up with these um, SI units and choosing their SI base units for that particular quantity. Okay, so the quantity of mass, okay, its base unit is kilogram. Okay, but when you take it to that table, this kilogram is already a multiple of 10. Okay, so for us to convert any mass, okay, we first have to like go back to the gram, okay, and then from the gram we can convert to any other what multiple there. Okay, so for mass, that's just how it was in their agreement. Okay, they chose kilogram here and not grams. Okay, so you can see it's the only one which is unique here. All of these have ampere, Kelvin, Morse, candela, meter, second, but for mass there we have a kilogram. So this was just based on their agreement. Okay, there's nothing that is unusual there. Okay, all right, so I have these questions here.
Asking questions that you know, as we need to learn, and then you're disturbing us because everyone knows that that's how it is about what is the units that he was talking about.
Okay, so I've written down an assignment for you guys. Okay, so you can try it out and then you can send the questions. Okay, so this one here on number 2, it's an application to the field that you are studying, so medicine or whatever field that you are studying. Okay, so I put this question here specifically for your field. Okay, so here where is they are saying consider the following package label for nitro B vitamin complex, okay, health supplement. And then the first question here, they are saying which vitamin is present in the smallest quantity. So what do you think we should do there? Okay, so I'm just giving you a hint on how to answer this. So what you should do there is convert all these masses that you can see. Okay, you convert all these masses that you can see to grams because they are given in milligrams here, micro, I can see micro there. So convert all these masses to grams, okay, and then now compare those masses in grams. Compare which one is be the smallest. Okay, and then how many grams of what, you can do that. Okay, so try out these questions and then you can send your solutions. Otherwise, this is the lesson for today. Okay, so if there are any other questions, you can ask me before I end this class.
So, sir, on the no, can you hear me?
Okay, so Sheba start and then the other one. You're not asking your question. I'm waiting for your question.
Yeah, you said Sheba first, then me later.
Okay, sir.
Yes. Sheba, ask your question. We are waiting for you. Hey, hey, she's going quiet. Okay, the other one who had a question you can ask. Maybe she'll come in at the end.
Just on the PG, they're saying convert the following 3.9 grams to PG. I don't understand the PG.
You don't understand the PG. You go on the metric system, you're going to find the P there. So you get the value of that P.
Alright, so
that's
the
th-
questions.
that's a picogram. Okay, that's a picogram, the PG. So can you use what?